Today we will go over section 6.7, which is operations with vectors in R-cube. Previously, we learned that x and y components are represented by I and z for unit vectors in 2 dimensions. However, in 3 dimension, which is represented by R-cube, there is also the z component, which is represented by the unit vector k. So if we were to put that again, my z-axis magnitude for z would be 1 and the rest would be 0. So now my coordinates a, b, c can be represented by the algebraic vector. Now passing on to an example, write each of the vectors OP, OQ, and OR, and OS using the standard unit vectors. Starting with OP, we actually did a similar question previously in the previous chapter. So for this, my x component is 2. So I know the x component for the unit vector is represented by I. So all I'm going to say is 2i. Now I go on to the y component, which is 1. And I know this is represented by j, and so I can just say plus j. I don't need to put 1 because it's just 1. You can just write the letter. And I go to the z component, which is represented by k, so I can just say negative 3k. Same thing over here, let's go to OQ, and you guys can do the rest. Over here I have negative 3i, and plus z, and negative 5k. So that's it, you just get the number and put I, j, k, whatever it corresponds to next to it. Now, as for the second part, they want us to express each of the following vectors in component form. So now I have the algebraic vector, I just need to write the component form. Starting from OP, I know that this has 1 in front of it. So that means in terms of my x, that's just 1. J represents my y component, it has a negative 2 in front. So that means my y component is negative 2. I have k, which represents my z component, and it has a negative in front of it, so that would be negative 1. I go to OS, the next one. I see that it only has the z component. That means my x and y is going to be 0, while my z component value is 3. Same thing over here, I look at here, I represents my x value, right? So for OM, I represents my x value, which has a 2 in front. So that's my x component. I see that there's no j over here, so that's 0 for y. And I see it's negative 6 for the z value, so I just put negative 6. And this is the last answer for ON as well. When adding 3 vectors that are algebraic, we add x components together, y components together, which we did before in terms of adding 2 vectors in R squared, but now additionally we also add z components together to get a result. So as far as this one, we would be adding all of the values for i's together and to get a value for that. So we just remove I, j, k if we want to write it in the component form. Now the shape obtained here, shown on the graph, is not a parallelogram when adding 3 vectors. This is called parallelepiped. So given A is this, and B is this, and my C is here, determine each of the following, which is 2A minus B plus C. So here, all I need to do is plug the A value and B value and C value into what they gave us over here. So as a result, I'm going to get 2, and I'll put directly what I have for A. So right now I have negative I plus 2z and then plus k. Now I'm going to put my minus B, which is 2z minus 3k. And I'll do my plus C, which is I minus 3z plus 2k. Now from here, I can start by distributing this 2 into my brackets because it's multiplied, right? So I'm going to get a value of negative 2i plus 4z plus 2k. And the rest is the same for now. Now I'm going to take everything out of the brackets, so that means distributing this negative into the brackets as well. So I'll just take everything out. The next thing we do, like I mentioned before, put all x's together. Now I look at my x values. X value is represented by I. So here is an x value. Let me look at another I. The next I happens over here, and I don't have any other I. So we will put those together. So that means putting -2 I plus I together, okay? And we do plus another one, and then we put the y components together. I look at the y components, which is represented by jet. There's one over here, there's one over here, and there's one over here. So all I need to do is put them together. So now I have 4 jet, -2 jet, and -3. From here, the last thing is putting the k's together, which I can do plus 2k, plus 3k, and a plus 2k. Now, as a next step, I can take out I from this one, j from this one, and k from this one to get a value. So when I add these all together, I get a value of -I, -jet, and plus 7k. And that's it. Now, we learned how to take the magnitude in terms of r squared. Now we're going to learn it for r cubed. All you need to know about is whenever you have a coordinate, let's say a and b, which is in r cubed, then when you're trying to take the magnitude of it, all you need to do is take x2 minus x1, y2 minus y1, z2 minus z1 to get a value coordinate. But if you want to find the actual magnitude of it, the magnitude of the whole thing, then you put the root and apply the Pythagorean theorem, but you just add the z to it also. So the formula is actually the same as the previous one. So we'll learn with this question on how to actually use this formula. So in the question given, I have my two coordinates A and B, and I can already label that with whatever given to me. A is my first letter, B is my second letter. So I can directly say this is my x1, this is my y1, this is my z1, and this is going to be my x2, y2, and z2. Okay? And we need to determine first the AB and then the magnitude of AB. Now, whenever you have AB, not the absolute value of it, so this is kind of misleading. So whenever you don't have this, and when you have AB that it's asking you for, you find the coordinates given over here by applying this formula. Okay, so the next thing I'm going to do, I'm going to apply that formula for C, and when I do that, I have x2, and I look at x2, what's my x2? That's 4, and then I do minus x1, which is 7. Okay, and then I'm just going to put a comma, and the next thing is y2, so which is -7, negative y1, which is -11. So that's going to be going inside the bracket. The next thing is z2, which is 25, minus z1, so 13. Now when I add these all together, I get a value of -3 for my x coordinates, 4 for my y coordinates, and 12 for my z coordinates. And that's it for my C portion. Now moving on to D portion, when it's actually asking for the magnitude of it, now I'm going to apply the other formula, this one right over here. All I'm going to do is, like the last one, I'm just going to plug in whatever I have, x2, x1, whatever. When I do that, I get a value of root 169, which will give me 13. Also realize that previously in C, we actually found what x2 minus x1 is, y2 minus y1 is, and z2 minus z1 is. If it's easier, if it's like back to back like this, you can directly plug this into here. So you would plug in -3 onto here without dealing with 4 minus 7 again. You will plug in 4 directly over here, and you would plug in 12 directly over here, and all you need to do is square them. Now, if you have any questions, let us know from our website and go to the forum section. If you have any additional problems that you would like us to solve, we can send you the solution to your problems.